So we are here for the Science of Life Club meeting regarding Chapter 3 of Idols of the Mind versus True Reality by Dr. Bhimada Vapuri from the Princeton Bhaktivedanta Institute. The third chapter is Reconsidering, the Unreasonable Effectiveness of Mathematics and the Natural Science. We are going over this chapter after last week's meeting where we had a professor give a presentation on faith and math for almost an hour. So now we look forward to getting another perspective on that topic from this book. So the title of this chapter actually comes from a paper that Eugene Wigner gave around the 1960s. He gave this paper. Eugene Wigner is a theoretical physicist who won a Nobel Prize in 1963 in physics for his contributions to the theory of the atomic nucleus and the elementary particles. So that's significant because as someone who studied physics, he didn't just blindly subscribe to the idea that math completely describes nature, like a lot of people do these days. He was very much aware of the limited degree to which math actually applied to nature. And he was a Nobel Prize winning physicist. So Eugene Wigner said, "I would say that mathematics is the science of skillful operations with concepts and rules invented just for this purpose. The principal emphasis is on the invention of concepts. We do not know why our theories work so well. Hence, their accuracy may not prove their truth and consistency." So basically, Wigner said that math is a complete system in the mind, independent of observations in nature. It just requires a pencil, paper, and mind to work it out, so why should it have any application to nature? So what do we mean by that? Well, we're going to look at apples, basically. We brought it up last week, right? Why does the number one apply to a single apple? And when we have three apples, when we say three apples, like, what are we really saying? And once we understand that, is that actually true, right?
And why is it an apple?
No, we're okay with it being an apple. It's about how numbers apply to the apple. Because each of them are different. The apples are different, you know? Like, they could be a different shape, different color, different weight, even if they're the same species of apple. But 1 plus 1 plus 1 means you have three things which are identical. And now you're adding these three identical things together to form a new identity, the number 3. But that doesn't apply to those apples. They're not three identities. They are different from each other. So it's only very loosely applicable. And we brought that point up to Dr. Vogel last week, and she agreed, and she likened it to the whole triangle thing, where when you draw a triangle, it never is actually 180 degrees. So in the same way, of course, these apples aren't really three apples because they're not all the same. It's only in the mind of the mathematician or scientist that the perfection of mathematics or the ideal of mathematics actually exists. It never actually exists in nature. So that's like a big point. Because here in the university, maybe we don't experience it so much, but on one of the forums of the Bhaktivedanta Institute, you get these folks who are like published academics and scientists who are very much convinced that mathematics will reveal the truth of reality to you. Mathematics is the truth of reality. Very super gung-ho about this idea. So it's a little hard to see why this is relevant to talk about here in some ways. But once you meet people like that, you see how they weren't introduced to this kind of thing, or if they were, they completely just ignored it.
And one off the other.
And now they think that everything is numbers. Like that tree that we're looking at, its identity as a tree is abstract. Really, it's like it's an equation. It's a bunch of numbers. It's
volume, length.
It's volume, length. Even photosynthesis, they have an equation for photosynthesis,
Yeah.
But they can't use that to make something which undergoes photosynthesis. So then how can you really say this equation is photosynthesis? Like, that equation doesn't help you build something which can undergo that process. You can only find something in nature that already exists, completely independent of humans as far as its origin. Obviously, nothing in nature is independent of each other, so all the plants and all the humans are interconnected. But as far as its origin goes, all those plants have nothing to do with human creation. People didn't build nature. So the photosynthesis, all these things, they exist in nature in a plentiful way, but we can't make a single leaf that undergoes photosynthesis. So our equation, like, is useful for some calculations, but it doesn't actually help us make something undergo photosynthesis, not at all, you know?
Absolutely.
So
well, what was she saying last week with the book where it was like, that's what I was getting at when I said, is it even an apple? Like, it's just a social agreement that we call it an apple. I wasn't saying, like, it's not an apple, but like,
yeah.
It doesn't have to be an apple, it's just a thing. Like, it's what we agree to call the thing. Like, this is a computer, why not? Like, you know what I mean?
No doubt. So, yeah, I mean, what we call any object in our particular language, of which there are many languages in the world, is obviously a social agreement. And that was her point with a circle and a cube. But we have to be careful and not think that the object which is being described by that word doesn't have a determinate identity have to be careful. The objects in nature are never independent of consciousness, but at the same time, they have an existence in themselves, which our consciousness also conforms to. So it's not that the apple, we can think it's a banana or a tripod, and all of a sudden it like becomes that. There is something there which has a real existence, which has determinate qualities, but how we refer to those qualities, I mean, that's a social agreement, but there is something which is existing in itself. Philosophers use the phrase in itself and for consciousness. These are the two aspects of any object.
Well, to not attack that, but to talk about that from a science perspective and how I'm learning about it, like the things that make up a tripod aren't the same things that make up an apple. Like, the molecules and the elements and atoms that are in an apple are not the same as in a tripod, which is what I feel like what you're trying to get at. Like, they're not, the agreement that we call a tripod, right, isn't the same thing as the agreement that we call an apple, which is why there's the distinction between the two, and they have two different names, and one can't be the other, because they're not the same thing. I don't know, maybe I'm...
Remember when we saw Professor Spinella's talk? Mm-hmm. And one of the broadest general idea that he presented was all objects that we experience are really just a mental representation. So you're not seeing a tripod, you're not seeing an apple, you're seeing a concept that's in your consciousness. So everything is in consciousness. This is like,
okay.
Right?
Something even better. I just saw this thing, like, what's the first thing? When you stop breathing, what's the first thing to go? Like, your lungs don't stop, your heart doesn't stop. Consciousness stops. You pass out, and then you're not in reality anymore, or your eyes aren't open. Like, if you don't have oxygen, you pass out, and the other parts of your body are still functioning. The first thing to go is your consciousness.
Okay.
That's all I got.
What about that?
I'm just mentioning that, like...
But not every instance of someone being unconscious means they're dead.
True.
So if you want to talk about the relationship of consciousness to life, which is a super relevant topic, then it's that the presence of consciousness in an object that we encounter in the environment tells us that it's alive. And there's a difference between things that are alive and things that aren't alive. Because we find some objects that aren't conscious, and we find some objects that are conscious, like animals and other humans.
So because this can't breathe oxygen, we don't call it conscious?
Not because it's not breathing oxygen. I mean, like, we would say and like a fish is a cognitive, and they're not breathing oxygen, so that's not the basis of determining it. It would be it's demonstration of it being for itself. It's acting on its own behalf. So it's not just an external purpose. That mouse only does something when an external force is applied to it, like your hand. There's no internal impetus in a mouse that will cause it to do something. But for anything that's living, including a single cell, there's an internal motivation that will cause it to do something. Stuff from outside the cell or outside the animal can also make it do something, but it can also do things internally. There's an internal purpose there, and it can act on behalf of that internal purpose. So that's like a distinction between living and non-living. So math can't touch those internal purposes. It can maybe give you a length, width, height, depth, curvature, but those are all external mechanical properties. It can't give you, what decision am I going to make right now? You didn't see it coming. Right? No equation is going to tell you if I'm going to slap you or not.
Psychological one maybe, but
yeah, but that's like predictive behavior. That's not a mathematical equation with numbers.
Yeah.
So that's the thing. Consciousness, math exists in consciousness, but consciousness is beyond that math. So math can't touch what is beyond it.
I think you can, it's not math, but you can use what you know about psychology and human behavior to really get a good prediction of what somebody is going to do and what decision they are going to make based on all these factors that can, like, in a way I see, but you can be, it can be wrong, absolutely, but you can get really spot on and close to knowing what exactly is going to happen in a scenario with a person and based on all these other things in their behavior. But continue.
Yeah, we're not denying the predictability, the capacity of prediction for various sciences. That's just a matter of repeated experience and your capacity to study it and observe it and then use it to make a prediction. But to say that math is fundamental and can apply to all things in nature, including conscious entities, to reduce the function of consciousness or psychology to mathematics is to make it impersonal, is to reduce it to like super bare bones, abstract qualities that don't really relate to the lived experience of that individual. It's useful for an external exploitation of that thing, like how you want to use it in a mechanical way, but it doesn't give you any kind of deep insights about the thing in a deeply fulfilling, purpose-oriented perspective. It's just kind of how you can exploit it mechanically, That's why mathematics and architecture go so well together, because you're taking an object and you're trying to externally exploit it, build it, bend it, make it do what you want. And that's fine for something which is just mechanical, inert, but
they're like saying psychiatry and psychology, diagnosing people with things, like, to me, that you can do that using not an equation, but like they have this and they have these two things, but like it doesn't make much, like there needs to be maybe another couple pieces that will give you over here.
Say that again?
So if you're diagnosing and you think that they have this and they explain to you there are these two things, there could be more pieces that lead to this condition. I don't know, maybe I'm confusing you, but like
You're trying to apply this to medical diagnostics.
I was, sure, medical diagnostics. But what I was coming at it from is because you were talking psychological, and there is more to it where it's like more than bare bone and black and white, but I think applying bare bone, black and white techniques to getting to the bottom of what's going on and why they're feeling this way is very helpful.
But how would mathematics help it?
I'm just like, it's not math, it's not numbers, but it's like using mathematics to say like this, all these factors give you this, and like different combinations of these factors and stressors and things that are going on with people's lives and what they're experiencing and what they had in their childhood will yield this. And if they have certain things over here, maybe it's not actually that, which is what the patient might think that they have, but it's this because you know that you have these different ones over here instead of the other ones that will actually yield this. Just saying, like using mathematical approaches can be very, very, very helpful in a lot of different areas, no matter what you're doing. Like the concepts from math apply, but I'm not saying it's numbers.
It's not number. Yeah,
No.
I see what you're saying.
It's taking all the factors in that you can see,
Yeah.
seeing the whole picture, putting the pieces together to find the answer or solution.
Yeah.
Is what maybe I'm not
No,
articulating it the best way I can,
yeah,
but
you articulated it fine, and yeah, there's no problem with that. What the book is addressing specifically just the numbers, the reduction of these things to numbers, which is, like we said, at the university, in psychology, even in medical, like you might never encounter that, but there are some folks who are very gung-ho about numbers are the real thing.
helpful, but
they have it has its role, but it's not everything.
No.
So this gives a little bit of a history. Leibniz, some philosopher named Leibniz, dealt with this in his Identity of Indiscernibles. I'm going to close the door a little bit more. Because we start talking about AI at the end, so let's see if we can do it. Yeah. So this gets back to that whole model thing, the map and terrain. Math in some way gives you a abstract map of nature, but that's not the terrain. We talked about that already. And then Einstein himself acknowledged the limitations of mathematics. He said one reason why mathematics enjoys special esteem above all other sciences is that its laws are absolutely certain and indisputable, while those of all other sciences are to some extent debatable and in constant danger of being overthrown by newly discovered facts. It is mathematics which affords the exact natural sciences a certain measure of security, to which, without mathematics, they could not attain. At this point, an enigma presents itself, which in all ages has agitated inquiring minds. How can it be that mathematics, a product of human thought, which is independent of experience, is so admirably appropriate to the objects of reality? Is human reason then without experience, merely by taking thought, able to fathom the properties of real things? In my opinion, the answer to this question is briefly this. As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. So you can find this quote in Einstein's, I think it's a letter or an essay called Geometry and Experience. It says that as far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they don't refer to reality. So then the book goes into the development of how science got to the place where they think mathematics, once you have cemented a scientific theory in a mathematical equation, then that basically proves its validity across all spheres. How did we get to that place? It started with Galileo, who lived in 1564. That's when he was born. He basically gave this idea that the book of nature is written in the language of mathematics. That sums up the whole idea. The book of nature is written in the language of mathematics. So, acknowledging that mechanistic paradigm is oh yes. So this is also at the heart of the whole idea that life is reducible to machines, that a robot can replace a human. Like that whole idea, you can kind of trace how did we get to that kind of crazy idea. If you trace back the thought, the development of thought, it gets back to this idea that mathematics applies to everything, then you can see everything in a mechanical way. Now that we see everything in a mechanical way, we can exploit the environment and create these machines more effectively. now we have technology, now we have robots, and because the whole time we were thinking that these numbers gave the whole picture of nature, not just a very limited part of it, now we have these robots and we think that they are us, only better. So we became blind to 90% of our capacity, and we think that the human being is simply this mechanical entity, 10% of what it really is, and the robot is better at that mechanical aspect of the human being than the human is. But it doesn't have that 90% capacity that we kind of forgot about. But because we're just putting ourselves in a little box, this 10% of human capacity, which is, has some mechanical capability, and the robot does it better than us, now we think it's going to replace us. And that you can trace that whole thing back to this kind of topic.
What's the 90%? I'm just
so
elaborate.
This
feeling and
feeling, but so this goes back to when we talked about the differences between mechanical, chemical, and biological.
Okay.
So a mechanical system, each of the parts simply have an external relationship to each other. This is a mechanical system. Literally. The machine, an external force, and comes and unites them. There's nothing internal to the mouse or the pointer or the phone which is bringing them together.
Gravity?
But that's external to them.
Okay.
You're right, but that's external to them. So now this is one type of system. Now the next level is a chemical system.
They're bonded together.
There's something inside each of the elements which makes them attract a certain kind. They're polar. So that's an internal, they have an internal capacity for attraction. It's not that you have to take hydrogen and you have to take 2 atoms of hydrogen, take 1 of oxygen, and you have to smash them together with an external force. Given the right condition, you give them a flame and activation energy, they will bond automatically because there's some internal attraction there, and they'll remain bonded. So that's one level above mechanical because there is some internal capacity uniting them there. But the thing about chemical systems is they remain polar. That hydrogen, that water molecule now can bond to methane or other things. So it's never kind of complete. It's always looking for something else. So now that gives us the criteria for the next classification of a biological system. So a biological system, all of its parts are not only internally attracted to each other, but there's a sense of wholeness, right? It's not always transforming its identity by interacting with something in the environment. Rather, it's maintaining its own identity by absorbing otherness. So literally eating, right? So you have an animal, or us, we have our identity, and when we encounter a blueberry bush, it's not that we become something different that is a combination of a blueberry bush and a human, right? We take the blueberries off, and they're a completely different kind of object than us, but then we eat them, and it breaks down and it becomes us. So what's not us becomes us. So there's a sense of wholeness which is maintained, and that sense of wholeness persists even through our interaction with things that are outside of us. With chemicals, that's not the case. It's not that hydrogen, it's not that a water molecule meets methane and it absorbs the methane and remains water. They react again, and now you get a methane hydrate, like some crystal gas under the ocean. So it's always making a new identity. It's never maintaining its identity. So you have these 3 categories: mechanical, chemical, biological.
And machines are only mechanical.
Only mechanical. Everything about them is, you have to have an engineer come and put them together. So these clear distinctions. And so that internal force that is making these biological systems remain what they are, that's not something that you can measure with numbers. Again, numbers kind of give you the aspect of that organism which is mechanical. They can tell you how tall it is, how dense the bones are, or stuff like that, but it's not telling you the cognitive decision-making cooperation between these living cognitive cells, or how they overcome novel problems that they never encountered before in innovative ways. You can't touch that with numbers. So it only gives you a very superficial, abstract idea of a living entity, volume, density, those kind of things. Right? So Descartes, after Galileo, Descartes was the next figure in modern science to solidify this mathematized vision of nature. So first, Descartes separated mind and matter. He said they were two separate substances, and that scientists would focus on studying the matter portion. And then he gave us the Cartesian plane, right? The Cartesian plane, the coordinate system is Cartesian means Descartes. So it comes from him, the XY axis. And so he applied that, and this is how we get this spatial, grid-like approach to viewing space. And then after him, after Descartes, now we have Newton. And so Dr. Pori says something very interesting in the book. The mathematical bones of Newton's Principia Mathematica were taken by modern physics and presented as a mechanical model of the universe without the pantocrator. So what he means by that is Newton actually, although he basically is the first one who gave a very concise view of a mechanistic universe, at the same time he saw God as necessary for maintaining the stability of the solar system, because if it was up to merely chance mechanical laws, then there would be way more collisions than there actually were. So he said there had to be an intelligence, which he called Lord God Pantocrator, which was maintaining the consistent, organized function of the solar system. So the argument is that chaos never produces order. Randomness never produces order. If you take a handful of sand and you throw it in the air, it doesn't matter how many times you do it, it won't ever land in the form of a sandcastle. Only an intelligence can come and build a sandcastle out of its, that's what intelligence is. It's an organizing agent. Randomness and chaos never produce an intelligible, organized system. So you require some kind of universal intelligence in order to have a nature which is repeatedly working, has these repeatable laws over millions and billions of years. You don't get something ordered, structured, repeated behavior through randomness. That's what we're saying is organization. You never get organization from randomness. You get organization through intention, which means intelligence. So the progression of science ignored that part of Newton. They just took his mechanical thing and they progressed in that way. So this was actually acknowledged, the negative impact that doing that had was acknowledged by a well-known scientist, and Dr. Pori quotes him in the book, in this chapter. So Dr. Pori said, "The problems created by mathematical mechanistic theories in cosmology have led to a crisis in the deterministic model that has ruled scientific thinking in the modern period. It has given rise to the theory of chaos that is now the reigning concept of the universe, which cannot simply be swept under the carpet by those who still support the doctrine of mechanistic science." In a 1986 speech James Lighthill said, real quick, James Lighthill was a British mathematician who is considered one of the greatest mathematicians of the 20th century. His innovative contributions to such fields as applied mathematics, aerodynamics, astrophysics, and fluid mechanics found such applications as the design of a supersonic Concorde jetliner and noise reduction in jet engines. So this guy said this: "We are all deeply conscious today that the enthusiasm of our forebears for the marvelous achievements of Newtonian mechanics led them to make generalizations in this area of predictability, which indeed we may have generally tended to believe before 1960, but which we now recognize were false. We collectively wish to apologize for having misled the general educated public by spreading ideas about the determinism of systems satisfying Newton's laws of motion that after 1960 were proved to be incorrect." So, do you know determinism? Have you encountered that word? Determinism is that when you accept that the universe is mechanical, everything is predictable, if you know the numbers, you know the equation, then determinism means you can predict any event in the future, no matter how far in advance, and there's no limitation to how many predictions you can make, given you have sufficient data. So determinism says you can predict anything as long as you have the data. There's nothing that happens which is spontaneous. That's what determinism means. Spontaneity doesn't exist. Everything is predictable as long as you have the proper data. So this guy is saying, and so determinism, the basis for that kind of thinking is Newtonian mechanics, the version of Newton that history took without his idea of God and all that. So this fellow, James Lighthill, we just read, he helped aerodynamics, jetliners, he was behind all this, so he knew his stuff, obviously. He said this idea of determinism based on Newtonian mechanics has been falsified as of 1960. Nonetheless, it was spread throughout the educational system as if it wasn't falsified, and so I'm apologizing for this. This is what he's saying in this quote. It's an apology. And this is the reference for the quote. Sir James Lighthill and Modern Fluid Mechanics, London Imperial College Press, 2008. So it's not so old. This is kind of recent. 16 years ago. Okay, so the next part of the presentation. This just reiterates the development of that idea that we were talking about, but then shows how there was a counter idea that developed in the history of thought that modern science pretends isn't there, but which offers a comprehensive viewpoint which is based on consciousness, not that consciousness is coming from matter, but that consciousness precedes matter, and that the idea of matter exists in consciousness as a very incomplete understanding of what is reality. So we covered Galileo, we covered Descartes. Then a fellow named John Locke said that objects are distinguished from space because for a long time they were thinking, I guess, so Descartes was thinking that a spatially extended object, so res extensa was the Latin word. Res extensa means being extended. So space was non-different from the object which was extended in space. Not that here is an object within a container and that container is called space, that this extended object is space itself. So then this guy, John Locke, said, no, here's an object and it's inside of space. So it's a very subtle thing, but it shows the development, the distinction and the development over time. So John Locke came, he died 50 years after Descartes. So this was, happening in increments of like 50 years, 100 years. Then a guy named Berkeley, he said that primary qualities. Yeah. Okay. So one thing that we didn't cover was something Galileo did also. Galileo, he said there are two kinds of qualities: primary qualities and secondary qualities. Since he assumed that the book of nature was written in the language of mathematics, primary qualities were mass, volume, measurable things. Secondary qualities were taste, smell, touch, color, because you can't quantify those things. So they must be inferior to the things you can quantify. That was his assumption. So this guy, George Berkeley, said those primary qualities, volume, so the reason he wanted to say they were inferior is because they're based on subjective perspective. This tastes sweet to one person, to another person they can have a disease called jaundice and it could taste bitter. Or this might be beautiful to one person and not beautiful to another. So it's just too subjective, not scientific, it's inferior to these other qualities which are mathematically discernible across the board for anybody. Then this guy, Berkeley, said those mathematical properties are also happening in consciousness just as much as those secondary qualities are. And so we were talking about social agreements before, right? Language. So all units of measure, right? The foundation of all units of measure is simply a social agreement. So we know very concretely that 12 inches is 1 foot, right? And what is it, like 5 feet is a yard or something like that. And those are all, we think, very concrete, like there's no other way. 13 inches isn't a foot, only 12 inches is a foot, right? And then you go down, how many centimeters in the inch, right? So you keep going down. What is the basis for the smallest unit of measure? There is none. It's a social agreement. You come up with, this is the smallest unit based on completely arbitrary reasons. There's absolutely no reason. Like, it's not like, and then once you have that arbitrarily established thing, then you say with all the confidence in the world, well, 12 of these is a centimeter, and then 16 of these is an inch, and then 12 of these is a foot. And you say it very confidently, as if it's like a scientific, irrefutable thing. But the very foundation, the smallest unit, is completely arbitrary. It's just a social agreement. We're going to start here, and then the rest, will seem more concrete. Right? So in that way, these mathematical properties of volume, mass, this is as much based on subjectivity as the colors, the tastes, the smells are. So then Immanuel Kant came. So the general movement here is showing that everything starts in consciousness. And then even the idea that matter precedes consciousness is occurring in consciousness. So this is something that we got really deep into that one time that you were to stay at the hospital and Alex came. Because we were able to, with the help of Dr. Puri, we were able to really make a concise description of what happens. So consciousness is first. And consciousness means it's conscious of something. There's a content, right? We think, and we're thinking of something. There's whatever that is, it's always a content within consciousness. Obviously, there's a connection between the two. So then consciousness projects that content as external to itself. It says the content of consciousness is not in consciousness, is external to consciousness. Then consciousness decides that that externally projected content is more important than the consciousness itself. So you have an externally projected content, which is now presumed to be more important. And then consciousness forgets that process. And what you're left with is consciousness, which is still conscious, that's its nature, perceiving something which is external to itself and presumed to be more important. And that's how you get matter. Any observation of matter is still going on inside consciousness. But the majority of people who are conscious of matter are not conscious of the activity of thought going on. They're just assuming that matter is first, that matter coagulates and makes living entities, and then you have evolution that occurs, and then you wind up with a human being with consciousness, which only emerges halfway through its development, and that's what consciousness is. And it's actually just neural correlates. It's just neurons firing. The whole description completely depends on what? Consciousness. An observation which is going on within consciousness. But it's not conscious of that. So you can retrace the steps of how that happens. Consciousness projects its content, it thinks it's primary, it forgets it did that, now it's conscious of an external content, and is trying to describe itself based on that externally projected content. But it's all happening in thought. So this whole development of history is trying to get to that idea. And so basically the moral of the story is that Hegel, this German philosopher, is the one who gave the most comprehensive account of this. And that science is not paying attention to that, and that it can solve a lot of its problems if it does. That's the whole point of this. Okay, so this is the last
steps back to go forward.
Exactly. So this is the takeaway. This is the last slide. Let us reconsider the appropriateness of devoting precious financial and mental energy to mathematical models of biological entities and processes, and invest in a more philosophically robust conceptual framework that can account for the dynamic and organic nature of biological and psychological phenomena. So this is something we encountered during our Science and Scientists conferences. Some of these people who are professional biologists, but that are people who are at the forefront of this cognitive revolution of biology, and they recognize that cells are cognitive, and that motivates their whole approach. They're saying to us, all this money for research, all this funding is going to people trying to make mathematical models of a cell, because they think that's what's going to cure cancer. And so this is where it really matters from a social perspective. So all these resources, all this money is going to fund mathematical models of cells, because they think that's what's going to give them the solution to cancer and distress and disease. And it's completely off base and misled. And they're going to continue to make more models and more models that are never properly acknowledging the cognitive aspect. And it's just wasting resources, people are suffering, and your problem's not getting solved. So that's one of the main reasons why this is so important. And then we have the last paragraph about how this all applies to AI. So AI is limited to syntax. Syntax means ones and zeros. While natural intelligence encompasses syntax and semantics. Semantics means you're able to discern purpose. So it means meaning. Semantic really means meaning. So AI is not responsible. This is an example of okay. So AI is limited to syntax, ones and zeros, following the algorithm, but it's not capable of semantics. It's not able to discern the meaning of the actions it's being assigned to do. So what does that mean practically? It means when you have an automated AI vehicle that commits vehicular manslaughter, kills another person, that AI vehicle, which is on autopilot, can't be held accountable for its action. So even though the human who's inside wasn't really driving, because the AI doesn't have semantic capacity, doesn't have capacity for meaning or purposeful activity, you can't hold it accountable to the extent of the law. So either you have the person who owned the vehicle is responsible, or the person who made the algorithm is responsible, or the person who made the vehicle is responsible. But the responsibility always falls back on the person, never to the AI machine, because of that categorical distinction. Its only capacity is syntax, following the algorithm, ones and zeros. It has no semantic capacity, no capacity for meaning. So it can't make a decision, oh, instead of hitting the person, I should go on the curb and maybe ruin the vehicle. It can't make that kind of decision. The other example is the inefficiency it takes to create an AI robot. So you need a whole lab funded by millions of dollars to create an AI robot, right? With like 10 people in it. But what resources do you need to make a human being? You need 2 people, even if it broke, right?
Broke as in?
Broke as in no money.
Oh.
Because to have one AI robot, you need a $1 million lab with millions of dollars of
Okay.
employees, right? You need lots of power to plug in all your electronics. You need so many resources are needed to make a single thing, right? And that single thing cannot in any way compete with the capacities of a living entity when the full spectrum of the capacity of the living entity is taken into account. Decision making, being able to make meaningful decisions, all that kind of thing. And so this superior organism also takes less resources. You only need 2 people. They are their own power system. You don't need to plug them into an external outlet. And the development takes care of itself. You don't need to hire people to nurture the robot, right? The womb takes care of all that. So from an energetic perspective, it's living entities are like infinitely times more efficient than the mechanical approach to building an AI robot. So from these 2 perspectives, we can also see another way in which the AI robot can never touch the living entity. It's so inefficient to make. It takes a crazy amount of resources, which are being taken from other places that they're necessary, right? You have starving people, but let's make $1 billion Boston Dynamics and make little Facebook live videos of a robot doing kung fu, right? So there's many perspectives that show the inadequacy. They're useful for certain things, but they're very, very limited from so many perspectives, and we need to learn about that. So the last statement is, essentially, AI's limitation to syntax is based on its computational mathematical foundation, where mathematics is fundamentally syntactical and not semantic. If AI is meant to somehow surpass that limitation, in an AI engineer or scientist's continual effort to mimic and surpass nature, it would require a critical reevaluation of the appropriateness of the mathematization of nature. A deep topic which Dr. Bhimata Bapuri considers quite important. So here we try to say, if AI wasn't saturated in the presumption that mathematics is the language of the book of nature, and rather it was, they used a whole different way of thinking in their coding approach, then that would also be a means for that AI to advance. So we're just saying bad things about AI and robots, that even if it wants to go beyond its current limitations, reconsidering the mathematization of nature would be a feasible way to go to try to find solutions to the problems that they're having. That's like the final point. And that's it.